a positive and negative number, we define this manner. Why I am discussing all these basic concepts today? Because if the fundamental concept you are steady, then you can go ahead, you can learn anything in this world. This is a very common topic, most of you know it. I am just telling you before you start anything actually. Now let us learn some properties. For A, B, C belongs to R, A greater than B and B greater than C implies A greater than C. Transitive relation. 7 greater than 6, 6 greater than 2, this implies 7 is greater than 2. Number 2, A greater than B implies that A plus C greater than B plus C. C belongs to set of real number. This is the symbol for belongs to. I am using it here. Remember, if you are not interested with these symbols, C will be a real number over there. Number 3, A greater than B and say C greater than 0. This implies that A into C greater than B into C, if C is positive. Number 4, for A greater than B and C less than 0, this implies that A into C less than B into C. If you multiply both sides by negative quantity, then direction of inequality going to be changed. And remember, all these relations I have given for strict inequalities. These are true for equalities also. I mean, we can draw an important conclusion. I am just writing one important conclusion from here, that A greater than B, like this one, and B greater than equal to C, this will imply that A greater than equal to C. Something like these are not so important, all these corollaries or conclusions from there. But for we'll keep on our mind that for equal to also similar relation exists. Equal to is not the case here. Our case is to do for inequalities, not anything for equalities. Okay. Now, in inequalities, I told you we mainly compare two quantities, two real quantities, two real functions. But function concept may be confusing for some of you. So I am not taking the concept of function here. I am just taking for any two algebraic quantities we can compare. How can I compare them? When you compare two algebraic quantities, suppose two quantities I am taking this manner, A, B. Two quantities I am taking in the form of function fx, gx. Two quantities I remember this manner, u1x, I mean one expression and another expression u2x. If we want to compare two quantities here, suppose you want to compare here, only three relations exist: equality, equal to, I mean greater than or less than. I told you, suppose you want to prove that A greater than B, it is enough to prove that A minus B greater than 0. Okay. So either you prove A greater than B directly or you prove A minus B greater than 0. Similarly, to prove B greater than A, it is enough to prove that B minus A greater than 0. This is the case of two functions also. Fx greater than gx. This implies that, so fx minus gx is greater than 0. For any two expressions, any two algebraic expression, this is the case. To prove greater than 0, we prove that difference positive. To prove less than 0, we can prove that their difference is negative. Clear? In this context, let us learn one important theorem here. If a1, a2, an B1, B2, Bn are all real numbers such that ai greater than bi for I equal to 1, 2, 3 up to n, then a1 plus a2 plus an is greater than b1 plus b2 up to bn. Why I am telling all these things before you start? Because sometimes you do manipulation directly. Then I will not explain where you have got this. Okay? So if this is theorem, you need to prove it. There are two real numbers and ai greater than bi given. All ai greater than bi. You have the idea 3 greater than 2, 7 greater than 4. This implies 3 plus 7 greater than 2 plus 4. That is 11 greater than 6. Always true. Similarly, 3 into 7 greater than 2 into 4. That is 21 greater than 8. This is always true. Now here, as we compare, we don't compare numbers here. Numbers we compare, but after learning the inequalities. Here, we compare mainly two variables, two expressions or two functions. So, I am denoting those quantities like A and B. Many quantities are there, A1, A2, An, one category, B1, B2, Bn, another category. And it is given that all AIs are greater than BIs. Then you can show that sum of AIs greater than sum of BIs. Product of AIs greater than product of BIs. Let me prove it. See how to prove this. First one. I told you two quantities, when you compare, you start with the difference. With difference, it is easy to prove. AI greater than BI given, we should remember. AI greater than BI means what? A1 greater than B1, A2 greater than B2. This way, An greater than B. Okay? So let me start with number 1. And I start with difference between LHS and RHS. This is what? A1 plus A2 up to AN minus B1 plus B2 up to BN. So this implies what? This is equal to what? Don't say imply. We are not solving an equation here. This is equal to what? I am taking B1 from here. Taking A1, B1 together. A2, B2 together. A3, B3 together. This way, An and Bn together. Okay? So, what do you get there? That A1 minus B1. Here when you are writing A1 greater than B1, what does it imply? A1 minus B1 greater than 0. What does this thing imply? A2 minus B2. So, this thing is positive. This quantity positive. This one positive. This one also positive. Sum of all positive quantities will be greater than 0. Am I correct? So, what have you proved there? This proof means you are solving a sum here, isn't it? So, this implies that LHS, you have started with this. LHS minus RHS greater than 0. This implies LHS is greater than RHS. Clearly, you have understood? So, first one we have proved. Theorem has two parts, I showed you. First part. Second part, how do you prove? That their product is greater than B1, B2, Bn like this. It's very interesting proof. Let us do this also. Proof of number 2. To prove number 2, I don't take all into consideration. I will be taking 2 only. Say, my logic is very clear. I'll prove that A1, logically I'll say A1, A2 greater than B1, B2. I'll prove. Don't worry. Logically, I'll prove A1, A2, A3 greater than B1, B2, B3. Logically, I'll prove so on. Then finally, I'll say that A1, A2, An is greater than B1, B2. Alright? Finally, I'll say this. So, how to prove the first one? To prove it, let us start with the difference. A1, A2 minus B1, B2 is what? A1, A2. I am taking a quantity A1, B2 subtracted from here, added also. So this is going to be what? This plus B2 you can take common. Now what is your idea about this? The right hand side. We have started with LHS. To prove this, we have started with LHS minus RHS. I got this. In this, A2 minus B2 is greater than 0, you know. A1 minus B1 greater than 0, you know. So this A1 is A1 and A2. You see the condition here are all real numbers. AI greater than BI. I said. Okay. So this part positive. This part positive. This part positive. So A1 into a positive quantity plus B2 into a positive quantity. And A1, A2, B1, B2 are all positive real numbers. So this has to be greater than 0. This implies that LHS minus RH is greater than 0. So this implies A1, A2 greater than B1, B2. I have done it for 2. You do it for 3 at home. I am not going to do it now because so many exciting sums waiting for us. You try it for 3 and then draw the conclusion. At least one you will do. This part proof you will do. Definitely you will do. If you cannot solve, write in the comment box. It's not coming. Okay? Definitely I will solve that. Now let us solve some basic problems on inequalities. Because today's class on basic inequality only. So we'll do basic problems. Prove that x plus 1 by x greater than or equal to 2. How to prove this? This is basic inequality, no? We don't know any advanced inequality here, standard inequality here. For x greater than 0, this will be always greater than or equal to 2. See how I am answering this question. Every time you start with the difference. You are comparing one variable with one constant. Comparison can be done what way? Variable with variable. Variable with constant. Constant with constant will do some difficult problem. We have to wait for that. Here I am going to compare two expressions. One is algebraic, the other one real one. I mean, that is also real. Left hand side also real, don't worry. Because x greater than 0. So let us start with LHS minus RHS again. This is x plus 1 by x minus 2. Take the LCM. X square plus 1 minus 2x. Numerator is x minus 2 whole square by x. This is greater than 0. Greater than equal to. Why? Because you said x greater than 0. It means that x may be equal to 0 also. So we put greater than equal to 0. So what does this imply? This implies LHS minus RHS. Therefore, alright, you understand? Let us go for next one. For ABC belongs to R, prove that A square plus B square plus C square greater than or equal to AB plus BC plus CA. This is also not a difficult one, and we'll be starting with the same difference, that LHS minus RHS. Okay, let's start. LHS minus RHS. This time we have noticed that ABC belongs to a negative or positive, not stated, but this quantity always greater than this. What is this? You multiply and divide by 2. Understood? I am just multiplying by 2 and dividing by 2. Half into. Now, some of you might have done this manipulation before. I am just explaining that part only. My aim is clear. I want to make perfect square. From there, I'll decide that this part is always positive. From there, I'll say LHS minus RHS greater than 0. So, A square minus 2AB plus B square, I am taking together, plus taking together, plus taking together. Check previous step we got it or not. Because A square plus A square, 2A square is there, 2B square is there, 2C square is also there. 2AB subtracted, 2BC subtracted, 2AC also subtracted. A minus B whole square. So it is A minus B whole square, B minus C whole square, C minus A whole square. This thing is always greater than 0, you know. This thing is always greater than or equal to 0. Why? Because this one is a perfect square, can never be negative. Perfect square can never be negative. This also cannot be negative. Okay? But they may be equal. Under what condition the equality sign occur? Equality occurs when A equal to B equal to C. Now you got LHS minus RHS. This implies LHS is greater than RHS. Clear? It is proved. Now, this thing is just direct application of this inequality. But now you remember, if three quantities x, y, z are there, then x square plus y square plus z square is greater than x, y, y, z, z, x. Whatever may be the value of x, y, z, whatever the expression there for x, y, and z, this is always true. So you can say that it is simply next problem what I am going to do, it is simply application of that. How? Let me show you. But keep that is in your mind always. Let me give you the proof. X square plus y square plus z square. We have proved that greater than or equal to xy, yz, zx. Okay. So what I am going to do, I am taking let AB equal to x, BC equal to y, CA equal to z. Clear? Then see what change is there. Then this can be written as x square, y square, z square. You simplify the right hand side. It's coming to be AB into CA. If you open the bracket, E square BC means AB into CA plus AB into CB plus AC into BC. So all right there, it is coming of this form. Writing it with the confidence that I know that I will be getting it. So x square plus y square plus z square greater than equal to xy plus yz plus zx. Isn't it? You are going to prove this, but we have already proved in the previous sum. This is always true. So, given inequation is correct. Clear? Let's go for next one. A4 plus B4 plus. Very similar. Because we have proved that x square, any three real number, is greater than equal to xy, yz, zx. This time you take let x equal to a square, y equal to b square, c equal to z square. This implies this we are going to prove, but this is already proved. So this inequality is true. As this proof we have done correctly. Go for next one. Prove that m cube plus 1 greater than m square plus m, where m not equal to 1 and m greater than my. Okay, let us prove it by the same approach we have used in the previous sums. LHS minus RHS. So far we have used this. Let us start with this. LHS minus RHS, m cube plus 1, m square plus m. You agree? Given m is greater than minus 1 in the problem. M greater than minus 1. Okay? So, you just take this one as m plus 1, m square minus m plus 1, m into m plus 1. Isn't it? So, just factorize it. I hope you have understood the utility of factorization here. M plus 1 and this is m minus 1 whole square. Okay? What is m plus 1 and what is m minus 1 whole square? See, m minus 1 whole square always positive. M not equal to 1. So, there is no scope of getting m minus 1 0. As m not equal to 1, m minus 1 whole square is positive. Definitely positive. And m greater than minus 1 implies. So what is your conclusion about this? This is equal to a positive quantity. So, what is the proof? Same. That LHS minus RHS is a positive quantity. Comparison done. LHS minus RHS greater than 0. This implies LHS is greater than RHS. Clear? Done? You have understood? Let us go for another brilliant sum. Does the same approach works? LHS minus RHS. So far we have compared all sums like that only. Are you ready to compare this? You try once. Try. Prove that for x, y greater than 0, x not equal to y, this thing is true. You start the same manner. That LHS minus RHS. Take something common. Can we take an h common? No. What are the quantities can we take in common? From first two you cannot take. So you take from these two. X to the power 4, x minus y, and then from this one and this one, y to the power 4, y minus 6. Hope you have understood. Now this is going to be what? x4, x minus y minus y4, x minus y, isn't it? Again take x minus y, x4 minus y4, factorize it again. So x minus y x plus y, x minus y. Clear? Now x minus y is repeating. So write x minus y whole square, x plus y, and x square plus y square. Look at the sum. We got success probably here also. X not equal to y given. So this one is permanently positive. As x not equal to y, it can never be 0. X and y are not equal and positive. So this part positive, this part positive. So by comparing this manner, what have we got? For this sum also, we got the success. So it is a very powerful tool now. To prove LHS greater than or less than RHS, you start with LHS minus RHS. Here we have done LHS minus RHS, we proved greater than equal to 0. So this implies LHS greater than equal to RHS. It proves x5, y to the power 5, x4y plus y4x. Okay? Is that clear? Let us enjoy this kind of big inequations also. Read the sum. A, B, C, D are real numbers, all greater than 1. Prove that A plus 1, B plus 1, C plus 1, D plus 1 is less than 8 into A, B, C, D plus 1. What is given over there? That A greater than 1. A greater than B, no. A greater than 1. I mean all. A, B, C, D greater than 1. Okay? And this time LHS minus RHS checking will be very difficult for us. We will not go for it. Let us use the information given here. A greater than 1. What does this imply? A minus 1 greater than 0. Similarly, we can write B minus 1 greater than 0. So what does this imply? A minus 1, B minus 1 greater than 0. This implies AB minus A minus B plus 1 greater than 0. Therefore, AB plus 1 greater than A plus B. Am I correct? AB plus 1, we have proved that greater than A plus B. But we haven't got it yet. AB plus 1 greater than AB, it's true. But there is no scope of getting this expression. So what you do there, adding AB plus 1 on both sides. Or twice AB plus 1 greater than, you take A plus 1 together and then B into 1 plus A. So what does this imply? 2 into AB plus 1 greater than A plus 1, and here on factorization it will be 1 plus B or B plus 1. Do you see something over there? Have we done it already? Check once. A plus 1, B plus 1, left hand side, many more are there. But here it is twice AB plus 1. Okay? So we have got it for two expressions only. Two more are there. Let us try with C and D. But I am not going to do that. But again, what we have to do, we can try that similarly for C and D, twice CD plus 1 greater than C plus 1, D plus 1. Isn't it? So one thing is clear, if you multiply these two, take this one as number 1 and that twice CD plus 1 greater than, this is another one. If you multiply, then LHS is coming. Okay, multiply, let's see what happens there. So multiplying 1 by 2, we get is greater than A plus 1, B plus 1, C plus 1 and D plus 1. Have I got it? Have I got it? Okay, let me start this way. Just take the, because we have to get this thing on left side. A plus 1, B plus 1, C plus 1, left hand side. So you write A plus 1 and D plus 1 less than AB plus 1, CD plus 1. Okay. Now what to do? Now let us apply one trick over there that you have proved A plus 1, B plus 1 less than twice AB plus 1. Isn't it? Can we replace A by AB and B by CD over there? Let us write. From 1, I can write x plus 1, y plus 1 is less than twice xy plus 1. Because it is proved over there. For AB we have proved. If xy given, you can do it. But now what we are doing, take x equal to AB, y equal to CD. So does this imply AB plus 1 is less than twice ABCD plus 1? Do you see something? Do you find anything over there? Of course. Because AB plus 1, CD plus 1 less than 2 into ABCD plus 1. The transitive property let us apply. This thing going to be less than 4 into 2 ABCD plus 1. Isn't it? Therefore, this implies that this step, with the help of this, what I did there, it implies that A plus 1, B plus 1 is less than 8 ABCD plus 1. It's alright. Hope you have understood. Let us play with one more good inequality which will clear the concept, which will tell us mathematics is not bounded to our thinking always. It has its own pace. Problems are like that. We have to arrange ourselves. We have to rethink to complete the sum. This previous two types, LHS minus RHS, you can never do. And the concept I showed you here in the previous sum, it is a tricky sum, bit tricky sum, is not applicable for this. Sums are all different. That's why subject is mathematics, no? Here ABCD belongs to R given. You have to prove that 1 plus AB whole square, 1 plus CD whole square, plus A square C square, plus B square D square greater than or equal to 1. How to prove? What is the way? Is there a fixed method to prove it? You think? Is there a fixed method for it? No, we haven't learned it today. Today's class is based on that knowing concept of basic inequality only. We haven't learned any standard inequality. Even knowing standard inequality, you will not get any help. So what to do? Only thing we know, ABCD belongs to R. So when there is no way, one way is there, just expand and check and try to prove that it is a quantity, left hand side is a quantity which is 1 plus some positive quantity. So that you can always say that it is greater than or equal to 1. So let us start with expanding. It's alright. I've just expanded it. So what do I get here? There is no scope. Nothing we find here. So we go for grouping. A square B square, C square D square. Okay. And then these two you separate. Achha, there is another way, one just class 9-10 concept here. If I add 2ABCD here, then I can get I am adding 2ABCD, subtracting 2ABCD. So there is no problem about this part. This we can write AC minus BD whole square. But problem arises with this AB, CD. Twice ABCD is there. How do I accommodate all these things? So you write 2AB here, 2CD here. I have a 1 also here and another one alone. Why alone? Because I observe the pattern here. This is nothing but this kind of manipulation we have done. AB plus CD plus 1 whole square plus 1 and this part AC minus BD whole square. So what do you observe? this expression greater than 0. They are all real number. Okay, you say greater than equal to 0. This third expression greater than equal to 0. So this whole expression should be greater than equal to 1. Am I correct? A perfect square. Third one is a perfect square. 1 in between. So this is 2. Clear? Let us go for another very unusual sum. Is it? Looks like very unusual. Suddenly 1047, 2084, 10 and just XYZ are real numbers given. How will I prove this thing is greater than equal to that? When there is no way, you have to do one thing. LHS minus RHS you can start with. Or start thinking about the terms given over there. Is there any relation between the coefficients here, among the coefficients here? Check. We just observe that 1047 and it is 2084, double. But here it is 10, 10, 10. No link practically. Let us think this manner that x minus y we know greater than equal to 0 with xy real number, y minus z whole square greater than equal to 0, also greater than equal to 0. So this implies what? So one thing we can do, I need 10z square. Z is there also. I need 10 yz. Yeah, I need. But if I, for the sake of 10z square, if I multiply this inequality by 5, then I'll get 10 yz. And for 10zx, we multiply by 5. Number 2, number 3. And this one, I have to get from here 5, we are getting 5y square. 1047. So, I multiply this by 1042. Okay. Now what is happening? This is just manipulation. No fixed inequality there for it. Just checking whether I can get it or not. So just expand and write 1042x square number 1 5y square number 2 5z square 2zx plus x square. This is number 3. Add all these. Check. 1042 plus 5x square here. And 1042 plus 5. And minus 2084. xy minus 10yz minus 10zx and z square also there. 5 plus 5, 10z square is greater than equal to 0. Probably I have got check once. So keep 1047, 104 and 10z square on left side. and transfer remaining terms on right side. Am I clear? Hope you have understood. So it is not difficult, manipulative. You have to work hard to get the answer. Okay?